Okay, algebra kids. So we're going to do polynomial division today. And before we do polynomial division, we are going to do a review of division. So back in the day when you learned this, probably, I'm guessing third grade-ish is when you learned long division. I don't know about you, but I thought this is the hardest thing of all time. Math will never get harder than long division. I actually went home to my parents and was like, I'm doing college work in my class because we did long division today. I thought it was the hardest thing on earth. And now it just seems kind of cute compared with all the other math we've done. So the way you do long division is by setting up the division problem kind of like this. You make your little division house that I'm sure has a scary math name, but I don't know what it is. And what is the first step to doing long division? Go ahead.
Anything multiplied by 4 that can fit in this box, right? Or 500.
Right. So I really like the way you said that. She said, we want to see if there's anything you can multiply by 4 that will fit into 5. Another way you could say that is, what's the biggest number you could multiply 4 by that would be less than 5? So like 2, for example, doesn't work because 4 times 2 is 8, which is bigger than 5. 4 times 1 will work because 4 times 1 is 4, which is less than 5. Another way that you can think about this is, what is the whole number answer to 5 divided by 4? 5 divided by 4 is 1 with a little bit left over, so we just write the 1. So what's the next step after you do that?
I haven't done division.
I know it's been a while. Next we multiply. We do 1 and we multiply by 4, which gives us 4. 1 times 4 is 4. And then we subtract, which is 1. And then you bring down the 3. Exactly right. Same question. You can say, what's the biggest thing I can multiply 4 by that is still less than 13? 3. Or you could say, what is 13 divided by 4? Well, 13 divided by 4 is 3 with a little bit left over. So either way, the number would be 3. Right, so then we multiply again. 3 multiplied by 4 gives us 12. And then we subtract, which is 1. And then we bring down the 7. Good. 4 times 4 gives me 16, which is the biggest thing I can multiply it by. Or another way to say that is 17 divided by 4 is 4 with a little bit left over. Okay, then we do 4 times 4, which is, as Shelby pointed out, 16, which is 1. And now we don't have any more numbers to bring down. So let me show you the way that my elementary school teacher taught me to write a remainder, but I don't want you to write it because it's way wrong. The way my elementary school teacher taught it to me was wrong. My elementary school teacher said, whenever you get to the end and your remainder is 1, just come right up here and write R1. So you say 134 with a remainder of 1. Now I understand why my elementary school teacher taught me this, because we were in elementary school and she was trying to keep it simple. We hadn't learned about fractions yet, so she couldn't teach us how to write it in the actual correct way, which is that you still divide it one more time. I do 1 divided by 4 again. My remainder was 1. I do 1 divided by my divisor, which was 4, and I write my answer as 1/4. That's the correct way to do it. It would also be correct to write 134 plus 1/4. It would be okay to write it as a decimal, 134 and 25 hundredths, or 134.25. That's correct, but we're not going to write our polynomial answers in decimals today, so we're not going to. It is possible with just numbers. It's not possible with polynomials. Okay, so let's talk about how to divide polynomials. There's a couple of ways to do it. And I'm going to show you both of them. So this is a binomial, 2x plus 3, divided by a monomial, which is x. If you are dividing by a monomial, I'll put over here in my notes specifically, when dividing by a monomial. I can do long division just like we did with the 537 divided by 4. I can do long division that way, but it's much, much easier. This only works with monomials. It's much, much easier just to separate this into two different fractions. So I can separate this into the first part, which was 2x over x, plus, because there was a plus sign here, 3 over x. That is a much simpler way than doing long division. Now, eventually we are going to have to do long division, and we'll get to that in a little bit. But when it's divided by a monomial, I don't have to.
And plus, it's easier because you still have same denominator.
Mm-hmm.
Right?
Mm-hmm.
So you don't have to really change anything.
That's true. They've got the same denominator. That makes it really easy. Although when I'm looking at this answer that I wrote, 2x over x plus 3 over x, I do notice something that can reduce. I do notice some canceling I can do, which is in this first one, I have an x over x, which will cancel. X divided by x is 1. So I could then write my answer as 2 plus 3 over x. And that actually is going to be the best answer.
I thought we were actually
That is the simplified, reduced answer. Now, what we divided by there was a first degree monomial. It's just x with an exponent of 1. Let's do one where we divide by a second degree monomial, just for kicks. And this time we're going to ramp up the difficulty by not only dividing by a second degree monomial, but we're going to do a trinomial divided by a second degree monomial. Trinomial. So just try your best on this one. Right, guys? Just nomial your best. Am I right, kids? This is for algebra students only. Everybody else pipe down. Anyway, sorry about them, everybody. Very good. I'm going to separate this into 3 different fractions. 3 because it is a trinomial now. You are so right, but we got to be careful.
I have a question. I don't know if this is but remember last time when there was like a pattern that you can only do with like certain equations? Like AB.
Right, the cubic one, yeah.
Yeah. Is that possible with something like this or no?
Yes, it is. We're not going to get there for quite some time because it's pretty challenging, but yes. So that's a pretty decent answer, but it's not a reduced answer.
I know.
All right, go ahead.
All right, so 4x squared is going to cancel out. That would be just one of those.
Yeah, okay, good. So let's stop right there because that's a really good point. We have 4x squared over 4x squared, and Shelby said that's just going to cancel out. But then she clarified what she meant. Cancel out doesn't mean disappear. When we say stuff cancels, we mean it equals 1. 4x squared divided by 4x squared is not 0. We're like, oh, it's the same thing, it's gone. Anything divided by itself is 1. So good, okay? Yeah, so let's take this one piece at a time. 2 over 4 will reduce, won't it? That's 4 over 2. What will 2 over 4 reduce to? You put too much thought into this. What can 2 and 4 both be divided by? So it'd be 1/2. And then x over x squared, we have 1x on top and we have 2 on the bottom. So the 1 on the top will cancel with one of the 2 on the bottom. So just leave us x to the first on the bottom. Good. Minus, right? The 4 over 4 is 1, but the x squared is on the bottom of the fraction, so I have to leave it in the denominator. And there's our solution.
The only time something would cancel out and equal 0 is if it was multiplied by 5.
Right. Right. Or if it was subtraction, like if it was 4x squared minus 4x squared, then it would cancel out and be 0. But with division, cancel out means it equals 1. So that's how you do monomial division, dividing by a monomial. But of course, we do also need to know how to divide by a binomial. Right. Binomial is 2 terms. All right. And this we should mark in some way in our notes is dividing by a polynomial. We're mostly going to focus on dividing by a binomial, but you could use this to divide by a trinomial or whatever. We won't today, but soon. Now, when you divide by a polynomial, when you divide by a binomial, the thing that you have to do is long division, just like we did right at the beginning when we did 457 divided by 4. You have to do long division. So just like with our long division problem, that is such a good question. I bet your teacher's going to show you. Now, one of the things is the divisor here is in the wrong order. The 3w squared minus 5 is in the wrong order. We want to go from the biggest exponent to the smallest, right, in descending order. So I'm going to do w squared plus 3w minus 5.
So it's always an exponent first.
Right, exponents in descending order from biggest to smallest.
W minus 2 be just 2w?
No, just plain old constant. Okay. So if we go back up to our original division problem, the first thing we asked ourselves in this just old school plain number division problem was, what is 5 divided by 4? The answer was 1. Down here, we're going to ask ourselves the same question, except just about the w's. So question number 1 is going to be, what is w squared divided by w? W squared divided by w is indeed w. So the answer there is w, and I'm going to put the w in my problem on top of the w that I already have. So I'm going to put the w right there on top of the 3w. I want all the plain old w's lined up, one on top of the other. Now, in our old school division problem, what was the next thing we did? Well, once we wrote the 1, the next thing we did was 1 times 4, which was 4. So we're going to do the same thing here. We're going to do w multiplied by w minus 2. W multiplied by w minus 2. Use the distributive property. What is W multiplied by W minus 2? Mm-hmm. Very good. W squared minus 2W. So that's going to go right here. W squared minus 2W.
Oh, wait, so, I know usually in long division, you go with one number,
Mm-hmm.
right? And you just subtract it by the numbers that you multiplied with it. That's on top.
Mm-hmm.
So we're gonna treat this like an equation. We're gonna like.
An expression, yes.
expression.
Mm-hmm.
And do like 3W minus 2W like that, or just doing W squared?
It's actually going to be 3W minus negative 2W, because the next step in our long division problem was to subtract the 4. So here we're going to subtract. We're going to subtract the W squared minus 2W. So W squared minus W squared is 0. But what is 3W minus negative 2W? Minus negative is the same thing as plus, right? So it's really 3W plus 2W, which is 5W.
How many times can W run 5W?
That's the next question. You forgot one step. Up here, after we subtracted the 4 and got 1, what did we do? We brought down the 3. So here we're going to bring down the minus 5. And now our question becomes, how many times will W go into 5W? Or put it another way, what is 5W divided by W? $5W divided by W. Right? It's got 1, right? 1W. So the W's cancel and I'm left with just 5. It was a positive 5, so I'll put a plus. Now I'm going to take the 5 and multiply it by W minus 2. 5W minus 10.
Wait. So is that negative 5 minus 10? Or
It will be negative 5W minus negative 10 after I subtract them. Remember we subtract them? 0, and then negative 5 minus negative 10 is, that's just negative 5 minus 10. Negative 5 minus negative 10. It'd be 5, yeah. Now 5 is the remainder. If you were in Mr. Taylor's 3rd grade long division class, you would write R5, but you're not. So it's plus 5 over the dividend. We divided by W minus 2. The last step would be to divide by W minus 2. So the answer is W plus 5 plus 5 over W minus 2.
So if we have something left over, we use thing on the right as a base or what?
I think on the left. It's called the dividend. Or is that the divisor? Maybe the dividend is the thing in the house. I get them mixed up. The thing outside the house. Are you in this class? The thing outside the house is going to be the denominator of the remainder.
Oh, so the numerator is going to be what's left over.
Right, the numerator is the remainder, and the denominator is the, I want to say that's the divisor. Pretty sure the divisor. That sounds right. Okay.
That's a lot of questions. So I can be sure I'm-
I think that is a wise policy. You should ask lots and lots of questions, especially when you can ask them to an expert. An incredibly handsome, well-spoken expert who can do over 5 push-ups, sit-ups, crunches.
You can do push-ups? Apparently.
Okay, fine, I can't. Are you happy?
Now we want to see if you can or not.
I can't do a push-up, so it's fine.
I understand why.
I can do 5 push-ups easy. I can do 5 push-ups with Rowdy and Christian standing on my back.
Do it right now.
Wait, push-ups means gasping for breath and then dying, right?
Yes.
Oh, then no, I can't do push-ups. Okay. So I'm dividing by x plus 4. So the x plus 4 is the, yep, because it's a binomial. X plus 4 is the divisor, lives outside the house. X squared plus 12, but I'm missing an x. There's no just plain old x. There's x squared and there's a number, but there's not just a plain old x. So I got to put that in there. I got to put in a plain old x. Now, if I put plus x in there, I have now changed the problem. I have added an x into a problem where there wasn't one. But I can put in a 0x. That doesn't change the problem. I can add in 0 of something. Why am I doing that? Whenever you do long division, you need to have every single variable from the highest down to the lowest, because as you'll recall, whenever we divided it the first time, we stacked all of the x's on top of each other. I got to have an x to stack stuff on top of. That's always needed. It's going to really irritate you if this was like x to the 7th plus 12. Because then you'd have to do 0x to the 6th, 0x to the 5th, 0x to the 4th, all the way down. But I'm sure nobody will give you a problem like that.
I think I already know the answer. When we're dividing, we always use the first number,
Mhm.
and then after that.
For today, it's always going to be an x too.
Okay, so and then after we're done with the x, do we do the 4 or just done with that?
No, the only time you use the 4 is when you're multiplying it back down.
Okay.
So question number 1 is, what is x squared divided by x? X, which I stack on top of the x's. And then
Put x minus x down, right?
we multiply. X multiplied by x plus 4, which is going to give me, hold on, multiply by the 4 also. X squared plus 4x. Remember, the only time we care about the 4 is when we're multiplying. What do I do with that? Subtract it. Yep. Yep, 0. And then what is 0x plus 4x? How about just 4x? 0 plus 4 is 4. So no x's plus 4x's is 4x's. Then what?
We bring down the 12.
Exactly. Plus 12. Excellent work. And then,
How many times does x go into 0?
Ugh, that's terrible. Excuse me, everybody. I got to take this very important phone call. Sorry, everybody. You know what it's like when your honeys call you. And you're like, woman, I'm at work. And they're like, oh, I just needed to hear your voice. You know how it is.
No, we don't.
Okay, no, you don't. It's so annoying.
Like that.
I'm like, give me my space, woman. Okay, so 4x divided by x is our next step. Four x divided by x. The x's cancel, and I'm left with 4. It's a positive 4, so I'll do plus 4. And then I'm going to do some multiplication. 4x. Four times 4. Positive 4 times positive 4. Yeah, you got it. 16. And then you thought 4 times 4 was 3? You thought 4 times 4 was 12?
No. I thought 4 times 3 was 16, but
You thought 4 times 3 was 16? Okay, 4x minus 4x is 0. What's 12 minus 16? Good. Negative 4. Ladies, stop the chit chat. Brock, you thought 4 times 4 was 1? So my remainder is negative 4. How do I write the remainder? Well, my problem was my answer was x plus 4, and the remainder is a negative, so I'm going to do minus.
I know.
Go ahead.
It's a negative 4 over x plus 4.
You can do plus, I'm going to write it both ways. You can do plus negative 4 over x plus 4, or you can just do x plus 4 minus 4 over x plus 4. Both of those are perfectly acceptable ways to write your solution. I like this one the best. No, it's the same thing. They're both correct. The bottom one just looks a little like plus negative looks weird when you could just write a minus, but it is correct. One thing I've come to expect from this class is if you can write the correct answer, but in a really unusual and weird way, you will go for it. So I prefer correct answers written in a weird way than incorrect answers written in a beautiful way. It's what's on the inside that counts, or whatever. Does anybody have any questions about polynomial division, about monomial division, about my physical training regimen that keeps me in tip-top shape?
No one cares.
No? It's fine. You guys probably wouldn't be able to keep up anyway.
8.
By the time we get to lunch, my body is about 25% coffee. That's true. I will assume no questions on polynomial division.